Out of all the places in our solar system, Jupiter's moon Europa is probably our best shot at finding alien life. There's just one tiny problem. It's a death trap. Seriously, its surface is one of the most hostile environments you can imagine, a world stuck in an invisible, lethal storm of radiation. And yet, we just can't seem to stay away. Our most advanced robotic explorers are already on their way, and we're actually making plans to send people to this deadly, frozen world. So why are we so determined to colonize a place that kills you? If you were to stand on Europa's surface without protection, you'd get hit with about 540 rem of radiation every single day. That is a completely lethal dose, enough to make you incredibly sick and kill you in under 24 hours. The paradox here is just staggering. The one place we think has the best chance of hiding life is sitting right in a cosmic firing line. What kind of insane tech would it take to survive that? And what incredible prize could possibly drive us to even try? The answer is hidden beneath miles of ice, in a dark, secret ocean that could rewrite everything we know about life in the universe. To really get the danger here, you have to understand Jupiter. Earth has radiation belts, the Van Allen belts, but Jupiter's are on a whole different level. The gas giant's absolutely massive magnetic field, which is nearly 20,000 times stronger than our own, acts like a giant particle accelerator. It grabs particles from the solar wind and everything spewed out by its volcanic moon, Io, and whips them into a frenzy. This whole process creates an invisible donut-shaped storm of energy, and the Galilean moons are trapped right in the middle of it. Io, the moon closest to Jupiter, is a volcanic nightmare that gets blasted with around 3,600 rem a day. That's instant death. Europa is next in line, and while the dose is lower, it's still way too high for any form of life and a total nightmare for electronics. Even our robots have to be built like tanks to survive. NASA's Europa Clipper spacecraft, which launched back in October 2024, has its most delicate electronics locked inside a thick-walled vault of titanium and aluminum just to make it through the trip. The mission itself is basically a dance of avoidance. Instead of orbiting Europa directly and getting fried, Clipper will orbit Jupiter and make dozens of quick flybys to keep its radiation exposure to a minimum. This radiation isn't just a threat to future colonists, it's actively shaping the moon itself. The constant bombardment of particles changes the chemistry of the ice on Europa's surface, breaking down molecules and creating a cocktail of oxidants. While that's bad for life on the surface, this same process could, funnily enough, be one of the keys to life down below. Now, not all of Jupiter's moons get hit this hard. As you get farther from Jupiter, the radiation drops off big time. Ganymede, the biggest moon in the solar system, gets a much lower dose of about 8 rem per day. It even has its own weak magnetic field that gives it a little protection. And then you have Callisto. Orbiting way outside the main radiation belts, Callisto is practically a safe haven, getting only about 0.01 rem per day. That's a dose you can survive, and it's why most people think it's the best spot for a long-term human base in Jupiter's neighborhood. So the problem is pretty clear. The one place we want to explore the most is the one that seems to want us dead. So how on earth could we actually live there, let alone build a colony? Well, the answer isn't to build bigger walls on the surface, it's to go down, way down. The main idea for surviving on Europa is to live under the ice. That same thick ice shell hiding its ocean could be the perfect radiation shield for us. Just a few meters of ice would be enough to block almost all of Jupiter's deadly radiation, creating a safe space for a permanent base. Old-school concepts like the Artemis project from the 90s imagined us burrowing into the ice, making igloo-style habitats, or even hollowing out huge caverns. Of course, getting there and setting all that up would take a huge technological leap. First, there's the 1.8 billion-mile journey, which takes years. The Europa Clipper, for instance, will take over 5 years to get there, using gravity-assist flybys of Mars and Earth to pick up speed. A mission with a human crew would need something much faster, like nuclear thermal or fusion rockets, not just to cut down the travel time, but to carry all the heavy shielding needed to keep the astronauts safe. Once we're in the Jupiter system, the smart move would be to start with the safest spot. NASA's Old Hope study from 2003 suggested setting up a base on Callisto first, maybe by 2045. Callisto would be our staging ground, a home base where we could control robots on more dangerous moons like Europa from a safe distance. Imagine driving a submarine exploring Europa's ocean, all while you're sitting comfortably in a colony on Callisto. But if we want to put boots on Europa itself, the challenges pile up. Power would be a huge one. Jupiter is so far from the sun that solar panels have to be enormous. The Europa Clipper's solar arrays are over 100 feet long, making it the biggest planetary spacecraft NASA has ever built. For a colony that needs a lot of power, solar just isn't going to cut it. The only real option is nuclear energy, probably from advanced fission reactors, to give us a steady power source deep under the ice. We'd also have to learn to live off the land. The ice is the jackpot resource. It gives us water to drink, air to breathe through electrolysis, and even hydrogen and oxygen for rocket fuel. We could also mine the rock and salt mixed in with the ice for other key minerals. And our electronics would have to be revolutionary. Researchers are already developing things like silicon-germanium transistors that are tough enough to handle both the extreme cold and intense radiation on Europa. These hardened systems would be the brains of any base, running everything from life support to the robots exploring the ocean. Building a colony on Europa would be the most ambitious thing humans have ever tried. We'd have to become a species that lives inside worlds, not just on them. So why go to all this trouble? Why brave the radiation, the cold, and the ridiculously long trip? Because what's hiding under all that ice could change everything for humanity. Decades of watching Europa, from the Galileo probe in the 90s to modern telescopes, have given us overwhelming evidence that it's hiding a global, liquid water ocean under its icy shell. Its magnetic field data points to a conductive layer, which is best explained by a massive body of salt water. The surface itself is one of the smoothest in the solar system, which suggests it's young and constantly being repaved by the churning ocean below. Scientists figure this ocean could hold more than twice the amount of water in all of Earth's oceans combined. An ocean is cool, but what's really driving this obsession is what might be at the bottom of it. Here on Earth, deep-sea hydrothermal vents, volcanic cracks in the ocean floor, create hotspots of chemical energy that support entire ecosystems without any sunlight. It's totally plausible that similar vents exist on Europa's seafloor. Jupiter's gravity is constantly squeezing the moon, which could generate enough internal heat to power this kind of volcanic activity. If those vents are there, they could provide the three key ingredients for life as we know it: water, chemistry, and energy. Radiation from the surface could be sending down a steady supply of oxidants, a food source, into the ocean, while the vents release minerals from the moon's core. This mix could create a stable, habitable environment where microbes could pop up and thrive in total darkness, finding that life is the ultimate prize. The Europa Clipper mission is our next big step. It's not designed to find life directly, but it will check to see if Europa has the right conditions for it. Its 9 instruments will map the ice, search for hidden water, and study what the moon is made of. One of its most exciting goals is to look for plumes of water vapor shooting out from the surface. These plumes, which we think we've seen before, could be a free sample of the ocean below. If Clipper can fly through one, it could analyze what's inside and maybe find the first hints of alien microbes. When you look at Europa, you see this incredible paradox. It's a world that calls to us with the promise of one of the greatest discoveries ever: finding life beyond Earth. But at the same time, it's an incredibly hostile place, a radiation-soaked death trap that pushes our technology and our courage to the absolute limit. To go there would mean becoming masters of our environment in a way we've never had to before, building our homes deep inside another world. But the need to explore, to figure out our place in the universe, and to answer that huge question, are we alone, is one of the most powerful things about us. Jupiter's moons are a death trap, yes, but they're a death trap we have to explore. The secrets they're holding are just too important to leave alone. The Europa Clipper is set to begin its close-up study of the moon in 2031, and the European Space Agency's JUICE mission will also make a couple of important flybys. We are right on the edge of getting our best look ever at this mysterious world. What do you think we'll find? The building blocks of life, or maybe something more? Let me know what you think down in the comments. And if you're fascinated by our quest to explore the craziest worlds in our solar system, make sure to like and subscribe for more deep dives.